colleagues, friends, welcome. We are really delighted to have you online, and we are extremely happy and grateful to Manzoor for accepting to share his knowledge here in our platform. And we're really looking forward to be having a strong engagement with him around the work he has been conducting over the past few years. If you allow, let me introduce the speaker, and after my introduction, he will kick off with his talks. Prof. Manzoor Qadir is an environmental economist with more than 30 years of experience working in water-related sustainable development through contributions to policy, institutional, and technical aspects of water resources and wastewater-related resources, water quality, environmental health. And he has a wide range of experience in the field, which makes him a great speaker today. He also has experience in the Middle East, North Africa, Central Asia, South Asia, and Sub-Saharan Africa. He leads at the United Nations University in UNWEH many global projects dealing with water in conventional water resources and technologies for water-scarce areas, and accelerate the implementation of water-related sustainable development goals. I mean, we know particularly SDG 6 being the SDG allocated to water issues. Manzoor has contributed to more international research consortia and initiatives, including the Comprehensive Assessment of Water Management in Agriculture, International Assessment of Agricultural Science and Technology for Development, Global Wastewater Initiative, UN Water Task Force on Unconventional Water Resources, and SDG 6, the Synthesis Report on Water and Sanitation. He has published over 200 peer-reviewed science and policy-related publications, and therefore we are very happy to have you, Manzoor, with us. The floor is yours. You can just share your screen and go ahead.
Thank you very much for the kind introductions. Really grateful for that. So let me stop. So my screen is visible to everyone.
Yeah, it is.
Okay,
thank you.
Good. Thank you very much. So today I'll be speaking on an important aspect of urban wastewater, which is considered as an environmental burden because of its composition. But there are opportunities where we can transform this environmental burden into an economic asset. Before diving into the subject, let me share with you a few slides covering what are the water realities, where do we stand with regard to water world. We know water resources and population densities are unevenly distributed across the world. There are countries in the region where annual renewable water resources are even more than 20,000 cubic meters per capita. For those of you who might not be familiar with the cubic meter, it is at 1,000 liters. But in contrast to that, there are other countries which are even less than 5 cubic meters per capita, which are several of them are in the heart of the Middle East and North Africa region. And on the left side, Canada, from where I'm actually speaking, falls in this category. In addition to water scarcity, there is another challenge with regard to water, which is water quality deterioration, which is happening across the world, but particularly in water scarce areas. And climate change is adding further complexity because of it's leading to environment, to rainfall uncertainty. At the same time, extended drought periods, which we have seen in the recent years and decades, mostly in dry areas. The projections suggest that more than 2/3 of the global population is expected to face water scarcity by the year 2030. And if we look at the future projections around water resources, after Middle East and North Africa region, Sub-Saharan Africa is expected to become next hotspot of water scarcity. So why I'm saying this, the projections suggest, because population increase is the major driver in addition to the climate change impacts to drive the annual renewable water resources per capita. And if we look at here, so this is basically an average annual change in annual renewable water resources, and that's where the Sub-Saharan Africa actually falls. Europe is the only region where there are projections that there might be slight increase in annual renewable water resources, and that will be primarily due to the expected drop in the population of the region. The impacts of running out of water are multidimensional. So what type of options we have in addressing water scarcity challenge? We know that conventional water resources such as rainwater, snowmelt, river runoff, and easily accessible groundwater, they are not enough to meet the growing water demands, particularly in arid and semi-arid regions. So the countries and communities falling in these type of regions need to consider alternate unconventional water resources to narrow the water demand and supply gap. And that's where urban wastewater comes in, and its safe and productive use has the potential to address water scarcity. Just to share with you some of the stats about wastewater, where do we stand with regard to wastewater? So wastewater volumes are driven by four major drivers: population increase, urbanization, economic development, and better living standards. And if we look at where we stand with regard to the production of wastewater, and particularly these figures relate to domestic wastewater, the world at large produces 268 billion cubic meters. And just to give you an idea how large this volume could be, this is almost 3 times the annual volume of water that passes through Niagara Falls. And in other terms, it is about 7 times the volume of desalinated that the world produces from more than 20,000 desalination plants. So you just imagine there are so many desalination plants around the world, and they are producing water, but that they just produce 1/7 of the volume of the wastewater which is produced across the world. So that itself shows that there are large volumes of wastewater out there, and there is a potential to harness their contribution to addressing water scarcity. Wastewater volumes, because of the population growth and other drivers, are expected to reach 322 billion cubic meters by the year 2050. But if we look at where we stand with regard to harnessing the potential of wastewater, which is largely untapped, the reasons are that only 63% of wastewater generated is collected, while more than 1/3 it just remains uncollected and released to the environment in untreated form because we don't collect it. And if we look at the treatment dynamics, 55% of the wastewater undergoes treatment, while 45% is released to the environment untreated. And the challenge is that the wastewater management guidelines are partially implemented across the world. If we look at the global regions and see in terms of wastewater collection and treatment, we see there is a deep divide. Like regions like North America and Europe are almost collecting all the wastewater and treating most of it, while the regions like Sub-Saharan Africa it's just collecting about 20% of the wastewater, and the treatment is around 10% of the wastewater. If we divide these countries or group these countries into 4 categories in terms of economic groups, in terms of low income, lower middle income, upper middle income, and high income countries, we see again there is this divide even gets deeper, where low income countries hardly collect 10% of the wastewater they generate and just treat 5%. And these numbers also include the secondary treatment of wastewater. So any type of treatment is considered here in these databases. So there are multiple challenges to wastewater management. One is we are paying little attention to aging water and wastewater infrastructure. It's not only the problem with the developing world or the global south. The global north and developed world is also facing another type of challenge. These countries established wastewater treatment plants back in the 50s, 60s, and 70s, and those are aging infrastructure. And more recently, the British Prime Minister was briefed that just to improve the Thames water infrastructure, there is a need for 15 billion British pound. So that itself tells us that the problem is different in terms of developing world, where the wastewater, largely the wastewater is not collected, and even if it's collected, the treatment levels are not adequate. While in the developed world, the infrastructure is aging, and that also needs immediate attention. Wastewater composition is also changing. So that's another dimension, that whatever the wastewater treatment plants, we need to upgrade them because there are more contaminants of emerging concern, microplastic and stuff like that. And climate change is fast tracking water quality deterioration. There are limited financial resources, at the same time lack of skilled human resources, which are restricting the management options. The issue is particularly in case of the developing world, still public sector largely deals with the wastewater collection and treatment, and that's where the funds are not appropriately allocated because of the low priority of wastewater treatment. And that's where the limited financial resources become another challenge in terms of wastewater management. As a result, somebody will have to pay the cost, whether if we invest on wastewater treatment or expose that untreated wastewater to local populations. Then our studies have shown that there is a high prevalence rate of waterborne diseases such as gastroenteritis in wastewater irrigated areas. And if we look at the health cost, that is about 73% higher than the freshwater irrigated areas. So what I'm trying to say is that on one hand, we need to capture and treat the wastewater which we are not capturing, but at the same time, I'm also emphasizing that the conventional wastewater treatment is not enough to eliminate all risks. So we need to upgrade our wastewater treatment systems because of the emerging pollutants, pharmaceuticals, cosmetic products, microplastics I just explained. And accordingly, based on the composition of treated wastewater, we need to select appropriate crops which are in line with the quality of wastewater. At the same time, there is improving the quality of reclaimed wastewater using advanced treatment options can significantly reduce human dietary exposure. If we look at the world at large, where we stand in terms of achieving SDG 6, and particularly SDG 631, which deals with wastewater, the world is off track. And the way we are doing with the business as usual in terms of addressing wastewater treatment, we will miss this target by the year 2030. So there's a need to harness the potential of wastewater and for different purposes. And I use 4 A's for that in agriculture, aquaculture, agroforestry systems, and aquifer recharge. And this depends on the composition of the treated wastewater, and then it can be allocated to one of these uses. There are also small uses in industrial processing, heating, and cooling systems. And if we collect all that wastewater and treat it and reuse it in agriculture production systems, this has the potential to irrigate 30 million hectares, even without dilution. So wastewater is not just a source of water. It contains other precious constituents such as precious metals and nutrients. And if we just look at 3 major nutrients, nitrogen, phosphorus, and potassium, about 8.3 teragrams are embedded in them. So just for the sake of clarification, 1 teragram is equal to 1 million metric ton or 1 billion kilograms. And just to again compare the mass we are talking about, so this is comparable to 25 times the mass of Empire State Building. So here we are talking about very large mass of nutrients, and since we don't treat 45% of the wastewater, so those are released to the water bodies, and then there are issues like eutrophication and other water quality challenges. But if we are able to collect all this wastewater and treat it, then in addition to the benefits that we are talking about use in agriculture and other sectors, there is a water quality improvement resulting in minimized eutrophication. Another valuable aspect of wastewater is the energy embedded in it. And we have seen now there are more and more wastewater treatment plants which are coming up, which are energy neutral, or in some cases even energy positive. So what we used to see before that the wastewater treatment plants are sink for energy, and energy they take a lot of energy. But now recent interventions have suggested that the energy embedded in wastewater can be captured and used to power these wastewater treatment plants. And again, for comparison, how much energy it can be captured and utilized in terms of households. So that energy is enough to basically power 112 million households, or in other words, 374 million people. And these energy dimensions will also increase by the increase in the wastewater volume over the years. So what can we do in terms of harnessing the potential of wastewater? There are different dimensions. We are talking about improving the wastewater treatment systems where they are to become compatible with the quality of wastewater. But at the same time, there is also a need to install, establish, rehabilitate the wastewater treatment plants in those areas where the wastewater is not collected and is released to the environment, water bodies in untreated form. So the key issue is that there is a need to enhance the political will to address wastewater management. Still, largely the policy makers and particularly the politicians, they feel that wastewater treatment is not seen by the general public. They are still very much motivated by building roads and the bridges which people can see. And they don't see really that level of motivation to, because they see wastewater treatment plant will be in the backyard of the city. People won't be able to even notice that. So why we are actually investing in wastewater treatment plant rather than just invest on something which is more visible and can be more politically attractive to them as well. And the other aspect is more at the national level planning system, integrating water recycling and reuse in the water policies and practices, and promoting flexible policy options, frameworks, which support the safe and productive use of wastewater. Then key issue is still, if you look at the water budgets of several water scarce countries, they just rely on the stats on fresh water that they have. They don't incorporate wastewater in their national level water accounting and water budgets. That's where it's very important. Once it is integrated into the accounting and water budgets, then the governments will have to pay attention in terms of addressing that segment of water resources management. Then they will have to invest on in terms of the wastewater collection, treatment, reuse, or safe disposal options. Another key issue is the institutional fragmentation. Apparently, there are a lot of large number of institutions you will find in a country dealing with wastewater, but they end up in overlapping responsibilities, and there is a lack of clarity of the roles. So that's where there is a need to really pay attention to arrange a dedicated agency or an institution responsible for the wastewater management in collaboration with other supporting institutions. So while moving from the policy level interventions, we need to consider integrating circular economy principles and applications. Thinking beyond the liquid part of wastewater, we can utilize biosolids, which is other part of the treatment system as a component in bricks or concrete. We can grow algae in nutrient-rich wastewater for biofuels and bioplastics. It can also play a critical role in building climate resilience, particularly in drought mitigation practices to sustain and support agriculture production systems, at the same time urban green spaces. In addition to that, it can provide ecosystem services, particularly to sustain wetlands, in supporting fish and shrimp farming. And there is another critical element that we usually do a very simple cost benefit analysis, but if we need to create economic value of introducing tax credits, subsidies, and other incentives for industries and businesses adopting circular wastewater management practices. So one hand, these practices should be incentivized and appreciated. At the same time, they would add value to the wastewater management systems. In terms of the financial mechanisms, there is a need to monetize recovered resources such as biogas, fertilizers, and reclaimed water. And we need to move gradually from subsidies to full cost recovery mechanisms for wastewater services. There's a need to create employment opportunities in resource recovery systems, maintenance and innovation. And more importantly, we have seen that in countries where the public sector collaborated with private sector, the pace of establishing wastewater treatment plants has increased. And that's where I think the government need to think about engaging private sector, because usually the public sector is responsible for wastewater management, and due to the lack of priority in terms of wastewater management, the investments or priorities remain very low compared to other sectors of importance. We are talking about the harnessing the potential of wastewater, but that cannot happen tomorrow or in the next couple of years or few years, because largely we still have untreated wastewater or inadequately treated water. So there is a need to implement interim strategies in countries with low treatment. And I listed a few of them, like interim strategies while full capacity wastewater collection and treatment systems are developed. At the same time, where the reuse practices are happening, there is a need to use protective measures. And in certain countries, there are non-functional treatment plants exist, but because of the lack of priority, they were not actually rehabilitated. That might be an easy option to invest, because with relatively less investment, these non-functional wastewater treatment plants could be transformed into functional ones. And in certain countries, it happens that the wastewater treatments were systems were established, the treatment plants were established years ago, in certain cases decades ago, to serve a certain number of people in that city. But cities have outgrown in number of people. So the wastewater treatment plants are still there with the same capacity. So basically they are overloaded. Wastewater comes, untreated wastewater comes in, goes through a filtration system, does not have adequate time to stay in the wastewater treatment plant for treatment, and then just passes through. Although I have talked to several municipalities, even the ministers dealing with the water and sanitation systems, they say these are the wastewater treatment plant and how much wastewater they are treating. But in reality, if you look at the composition of that treated wastewater, it's more like, you can say, a wastewater from where the solid particulates and other stuff has been removed. Otherwise, there is not really much difference in terms of its chemical composition. So before I close, I just wanted actually to share with you a framework that yesterday I was thinking about how we can summarize this whole wastewater treatment, wastewater management systems. There are three major intersections: managing the source of wastewater, then managing the treatment and its delivery, and the third one is managing the fit for purpose use in those four areas: agriculture, aquaculture, agroforestry systems, and aquifer recharge. So based on the composition of the wastewater, one can allocate that. While these are the three phases, there are interacting factors which should not be actually ignored in such type of planning. On the left-hand side, I mentioned monitoring and reporting, which is very important. We need to count the wastewater volumes, where do they go, and which are their paths. And at the same time, this can only be done if there are relevant policies or laws are available in the country, but they are also enforced or implemented. We need to select appropriate technology, as we have been discussing in this seminar, based on the composition of the wastewater. Where there is a need to upgrade the wastewater treatment system, one should do that. And where there is no treatment system, at least one should start with collecting all the wastewater and starting with the lower level of the wastewater treatment. And there is a need to create more awareness and advocacy, and in all segments of the society, to suggest that while on one hand wastewater is considered as an environmental burden, but at the same time it's a very valuable resource if we do appropriate wastewater management practices. Sustainable operations, particularly at the level of treatment and delivery systems, are essential to ensure that the aim of wastewater treatment, the goal of wastewater treatment is adequately achieved. And of course, without standards and guidelines, we will not know what is the composition of treated wastewater, and that's where we need to be actually careful that we know what type of wastewater goes into the system and what type of quality of wastewater comes out of the wastewater treatment plant, so that we can decide what could be the fit for purpose use of that wastewater based on its quality. So I'd like actually to stop here. And before I close my presentation, I have suggested here my email address as well. I'm quite sure there will be opportunity for questions and answers, but still, if you find there might be some later point of clarification or comment that comes to your mind and you like to follow up, feel free to write me on this email and I'll be happy to follow up on that. Let me stop my presentation, and I just thank everyone for the participation, and I look forward to the questions, comments you may have. Thank you very much.
Thank you. Thank you very much, Manzoor. This was very enlightening. We learned a lot from this presentation. We know in the literature, most of the work that actually does exist is mainly geared towards, water that already has reached a certain standard from a quality perspective. And therefore, having a presentation that speaks about wastewater issues is something that is very important for many countries that are actually trying to find a way to sort of diversify their water supply portfolio. And therefore, we thank you very much for that.